I want to take the time today to demystify AI agents a bit. I have no idea truly how useful this explanation will be for you, but this has been a useful way for me to think about AI agents and understand what they are, what they're doing, and what's going on with them. A lot of people think that AI agents are basically variants, special variants of the models that we have been using. They think that they are special models with special brains that allow them to have more autonomy or to act more independently. And this is actually not true. And I think this misconception has led to a mystique and some confusion around AI agents that I want to break down. So this won't be anything necessarily revolutionary, but I think it will be helpful to really understand and to make them accessible. AI agents are simply abstractions on top of existing foundational models, at least the way that they are built now. We can think of this as a stack. At the bottom, we have the model layer. This would be Gemini, GPT, Claude, whatever you're using for your agent. This model, as you may already know, works like a simple input-output system. You send it text and it sends text back. Now that is very powerful. It can do a lot. But it is an input-output system. It is stateless. It doesn't have memory. It doesn't actually truly know what you sent it 10 seconds ago. So when you're using these models in your browser, for example, the reason it feels like a conversation, like it remembers you, is because the app on top of the model is resending the history of your conversation every time you send a new message. So then the model reads the whole thread fresh each time. And it can generate a new text output that is relevant to the new question that you asked or the message that you sent, and includes the previous messages that you sent as well. But the point is that the model alone is actually pretty bare bones. It can't do things in the real world. It can't answer questions about your data because fundamentally it actually doesn't have access to these things. It doesn't have access to more than just the input of your conversation. So the question becomes, how do you get from a stateless text function to a system that uses tools and makes decisions? And this is where we start to get to an agent. This is where we introduce functions. And that's the next layer. What we can do is we can write code that acts as a tool for the model to use. And then we can attach a description of that tool for the model to understand what the tool is, what the code is, and when to use it. These tools are called functions. And with these functions and their descriptions, the model can know, okay, there's a function called query sales database that I can use with SQL and get back rows with SQL with sales data. Or there's a function called, read document that takes a file path and returns the text of that file. So the model still can't execute anything. It expresses intent. It expresses the desire to use these functions through a function call request. And your code receives that intent, that request, and it executes the function accordingly and returns the result. Now, you might wonder, okay, how does the model decide which tool to use if all it does is generate text? Well, the answer is that a function call request is still generated text. It is text. When a function calling is enabled, the model's input includes descriptions of the available tools and a valid form of output, being a structured message that names the function and provides arguments to the function. But the model does not actually execute the function. Your code executes the function. So the model picks up the function name and the arguments the same way it generates any other output, by predicting the next tokens based on the input. Your code then parses that structured output and executes the function. So there's nothing magical going on here, right? This solves the first problem that we talked about. The model can now get information that it wasn't given in the input because it can request that your code go and get that information, right? There's a limitation, however. The model makes a request, it gets a result, and it produces a response. But sometimes in the real world, many times actually, answering a question requires more than one lookup or more than one action, right? Or a lookup followed by a decision, followed by another lookup. So function calling alone can't handle that. And that's where we get to the agent loop, which is the next layer here. So instead of calling the model once, you call it in a loop. This is essentially when we get to something that we could probably call an agent. What we do is we send the input, and if the model returns text, you're done. If the model returns a function call request, you execute that function, you append the result to the conversation, and you call the model again. And you keep doing this until the model returns only text and not a function call request. And that is the agent loop. There is no new capability in the model. The only addition is that your code keeps calling the same function until it stops requesting tools, the same stateless function. The model makes a decision, your code carries it out, the model sees the result and makes the next decision, and the loop continues until the model determines it has enough information and produces a final response, which is not a function call request. So the word agent basically refers to this loop, right? This is basically the layer where a model is converted into an agent, because it keeps going until it decides through its reasoning capability that it is done. It keeps going until it says, I don't want any more function calls. This text is the final response, is the final answer, right? And so now we get to the next layer, which is the Model Context Protocol, or MCP. So in function calling, including with loops, you're defining each tool by hand, right? You write a Python function that queries BigQuery, for example, if that is the function or the tool that you're adding to your model. You write another one that reads from cloud storage. You write another one that accesses some other tool. Each of these requires custom code and a custom description. MCP, the Model Context Protocol, replaces that per tool custom work that you would have to do with a standard protocol. So an MCP server, right, exposes the capabilities of a tool in a format that any agent can discover and use. Your code still executes the calls, and the agent loop, if you are using one, is still unchanged, but what changes is how the tools are defined and connected. So the MCP server puts the capabilities in a format that any model that you are using as an agent can use. This is what the Model Context Protocol is. Again, it's nothing magical, right? It's powerful, but it's not magical. The practical consequence here is that for any service that has an MCP server, you do not need to write the tool function. You just need to connect to the server. And so for business logic, specific to your application, you would still write custom tools, but you could move toward taking an MCP approach that would standardize it, right? MCP is for tool connectivity, the way that HTTP or HTTPS is for web communication, right? It is a protocol. It is a standard. It is not a capability by itself. It simply standardizes the interface, the communication, without changing what the model can or cannot do. So again, there's nothing magical here. It's powerful, it's important, but it's not magical. One thing to note here is that although it is a higher layer of abstraction, the MCP layer that I have in this diagram doesn't necessarily actually build on top of the agent loop, right? You can have an MCP without a loop. It just standardizes the communication between the model and the tools, but it is a higher level of abstraction, and so it belongs above the agent loop in this diagram, in my opinion. All right, now for the next layer, the ADK. So up to this point, you're writing everything yourself: the loop, the session management, the tool wiring, the web server, the deployment configuration. Even if you're using MCP, you're still writing a lot of things yourself. The agent development kit packages the common parts into a framework, just like any software development kit. any framework that you use, with Python, for example, it abstracts away the common parts that people have to build. So you can declare an agent and hand it tools, and the ADK provides the loop. It manages the conversation state. It handles the registration of the tools, including MCP. So again, that's why it belongs above MCP in this diagram. It's a higher level of abstraction. It deploys to a managed runtime. The model, the tools, the loop logic are all the same, right? The difference is who writes the code, right? Who writes the boilerplate code? You, or do you use the framework that's been provided to you? And the ADK is basically that framework. So the trade-off here is pretty straightforward, right? If ADK's default behavior matches what you need, it removes a lot of work. If you need the loop to behave differently, if you need it to handle errors in a custom way, for example, if you need a very specific approval flow that the ADK does not provide, if you need retry logic that is not built in, you have to either accept what the framework offers you and use it, or you have to go back to kind of writing the code yourself and not using the framework. But the ADK allows you to do a lot of these things more conveniently and faster. And then above that, we've got no-code agent builders. One example of this that I have on the screen is the Vertex AI agent builder, right? And this removes code entirely. So even one step beyond using a framework, which takes care of a lot of the code writing for you, you have these no-code agent building tools, where it's kind of drag and drop, where you fill out fields, in a GUI, in a UI. And essentially you configure an agent through this UI. You point it to data, you select capabilities, and you can deploy it. And this replaces pretty much every layer below it. You do not write the tools. You do not write the loop. You do not choose a framework. The platform does all of that for you. In this case, if we're using Vertex AI, it would be Agent Builder. Now, there's a trade-off here, right? And there's a trade-off throughout this entire stack, basically. The trade-off is you are getting more abstraction, but you are getting less control, right? So you may run into a situation where you need to elicit behavior from the model that, the UI, the Agent Builder UI, for example, does not expose. In the same way that you may need a more custom approach than the ADK allows you to do. So this is kind of an overview of the AI agent stack. And when you peer under the hood, my point is that AI agents are not that complicated or scary. Of course, they can be complemented to actually implement and make work in the real world. But agents and agent-based systems are essentially abstractions on top of models that we are already familiar with. You're basically writing code around the models just in order to augment its capabilities and provide it with tools that, given a certain response or output from the model, it can keep using until it's satisfied with the result, right? And then there are layers of abstraction on top of that. So in the agent stack, each layer takes something that you were doing manually at the layer below it, and it helps to automate it, right? Function calling automates external access. It automates taking actions, again, through code. You are still writing code to take these actions much in the same way that you would do if you were not using an agent or using a model. The agent just provides certain outputs that determine whether or not that function gets called. The agent loop automates multi-step reasoning. The MCP, the Model Context Protocol, standardizes the connection, much in the same way that HTTP does for internet. And the ADK, the Agent Development Kit, provides an easy framework to do the boilerplate agent creation, the common things that you would want to take care of in order to build agents. And then we've got, even on top of that, the no-code tools like Agent Builder, which kind of put all of this together in a very user-friendly UI with no code. But at every layer, the trade-off is the same. You gain speed, you gain ease of use, you gain abstraction. You have to write less code. But you lose some control. You lose customization. And there are some situations in the real world where you would need that customization. So I hope this made sense. Tell me in the comments, please, if you found this helpful or if you found this confusing. And if you want more content about this, I'd be happy to create it. But that's it for today. Thanks so much.